Let's start by switching to folder view. Create a new folder named Crate on the Assets folder, open this folder with the File Explorer, and download TextComp from the Microsoft's DirectX text GitHub page. Save it on the Crate folder, get this Crate texture from the Dactylar Design DeviantArt site, name it as Crate JPEG, and download this fragile stamp texture from Pixabay. Open the images with an image editor, save the Crate texture as PNG format, resize the fragile texture with a height of 512 pixels and maintain the aspect ratio. Then square the texture as a 512 by 512 pixels with the stamp center, remove the background color, and save it as a PNG. Open PowerShell and use TextComp to convert Crate PNG to DTS format. Do the same for the fragile PNG texture. Go back to Visual Studio, switch to Solution View, add a Crate filter in the Assets filter, add both DTS files on it, open their properties, select all configurations, select the item type as does not participate of the build, set its content flag, open the NuGet package manager, and search for DirectX TK12 UWP. Install it. Go to PCHH, include DTS texture loader, go to vertex formats H, and declare a vertex post text construct. Declare its position and a XM float2 for the texture coordinates. Open CubeH and redefine the indices. Redefine the vertex type as vertex post text cord, and redefine the vertices, deleting the colors and assigning coordinates for the textures on each vertex. Rename CVE heap to CVE SRV heap. Add ID312 resources for Crate texture upload, fragile texture, and fragile texture upload. Add a static const export float for the y-axis translation delta, a float for the translation value of the y-axis. In QInitialize, rename CVE heapDesc to CVE SRV heapDesc, and add two descriptors to num descriptors. After cleaning the memory of the constants buffer, create two shader resource viewDesc, one for the Crate texture and the other one for the fragile stamp. And create two CPU descriptor handles, using CVE CPU handle as its origin. Move the direction of fragile CPU handle using offset and passing the size of the descriptor. Call Crate texture resource, passing the device, the command list, the Crate's texture path, the Crate's texture resource, its upload resource, and Crate SRV desk. Do the same for the fragile stamp texture. Call device Crate shader resource view, passing the texture, the shader resource view, and the CPU handle for both textures. Change the name of the shaders from Color CSO to Text Core CSO. In Crate pipeline task, create a new descriptor range for the shader resource views. The root parameters number to 2. Initialize range SRV with the init method, passing the SRV type, two descriptors, and the base register 0. Initialize the root parameter 1 with one descriptor in the address of the descriptor range of the shader resource view and with pixel shaders visibility. Delete the pixel shader root access from the root signature flags. Add a static sampler desk array with just one element, and initialize its elements in the following way. Filter as min-max-mip linear, address U as clamp, address B as clamp, address W as clamp, mip load bias as 0, max anisotropy as 0, comparison func as func never, border color as transparent black, min load as 0, max load as D312 float 32 max, shader register as Y, register space as 0, and shader visibility as visibility pixel. Change the parameters of desk root signature init from 0 samplers to the number of created samplers and the samplers. Change the declaration of the input layer change color to text color, and remove the V32 component. In Destroy Upload resources, release Create Texture Upload and Fragile Texture Upload. In Destroy, release Create Texture and Fragile Texture. In Update Constants Buffer, add the Y-axis translation delta. Create a world matrix by multiplying the rotation matrix to the translation matrix using an oscillator over the translation Y-axis value. In Render, create a GPU descriptor handle for the textures using getGPU descriptor handle for heap start, an offset of 3 elements, and the size of the descriptors. Assign the second descriptor table with command list set graphic root descriptor table with the index 1 and the text GPU handle. Go to device utils age. Declare a create texture resource function, passing the device, the command list, the files path, a reference to the texture resource, a reference to the upload texture resource, a reference to a shader resource viewdesk, and the texture format with RGBA8 unorm sRGB as its default value. Create a definition for the function using Visual Studio refactoring tools. In this function, declare a std unique pointer of uint8 arrays as DDS data, a sub-resource data vector as sub-resources. Call load DDS texture from file, passing the device, the image path, texture, release and get address of, DDS data, and sub-resources. Get the size of the texture in memory with get required intermediate size, passing the texture, 0, and an uint static cast with the number of elements in sub-resources. Call device create commit resource with the upload heap type property, known as flag, a resource desk buffer with the size of the texture in memory, the generic rate state, null pointer, and the IID PPV args of the texture upload. Call update sub-resources, passing the command list, the texture, the upload texture, 0, 0, and uint static cast of the number of elements in sub-resources and sub-resources data. Create a transition barrier with resource barrier transition, passing the texture from the copy desk state to pixel shader resource. Queue the resource barrier with command list resource barrier. Initialize the shader resource viewdesk with view dimensions as SRV dimensions texture 2D. Shader 4 component mapping as shader 4 component mapping, format as texture format, texture 2D, MIP levels as the number of elements in sub-resources, texture 2D most detailed MIP as 0, texture 2D resource min load clamp as 0, go to the folder view, add a new pixel shader named textcore HLSL, and a vertex shader named textcore HLSL. Go back to the solution view, and include this new file in the pixel shaders filter, and the vertex shader in the vertex shader filter. Configure the pixel shader as a pixel shader type. Its shader model as 6.1. In the output file as outdir shaders pixel shaders, file name CSO. In the vertex shader configuration, set its shader model as 6.1. Its type as vertex shader, and the output file as outdir shaders vertex shaders, file name CSO. Declare a world view projection constant buffer cbuffer using register v0, which will only have a world view projection matrix. Declare a vertex shader input struct with its position as float 3 and UV as float 2 for the texture coordinates. A pixel shader input struct with a float 4 as the rasterizer position, and a float 2 to pass the texture coordinates. Declare a main function returning a pixel shader input and receiving a vertex shader input. Calculate the rasterization position multiplying the vertex position to the worldview projection matrix. Copy the texture coordinate values. Copy these values to the pixel shader input struct and return it. Now move to the pixel shader. Declare a texture 2D array with the base register T0, a sampler state with register S0, the number of textures with 2, the gamma value with 2.2, calculate the inverse gamma with 1 over gamma, declare the pixel shader input, and the main function, which returns a float 4 and receives a pixel shader input. Declare a float 3 as texture color and initialize it as a 0 vector. Iterate each texture. Add to texture color the RGB values from the texture with sample function, passing the sampler and the interpolated texture coordinates. Return the color value of the texture, applying the gamma correction, powering the color to the inverse gamma and 1 for its alpha value. Compile the project. Run it. For some reason, the crate texture is not displayed and all its pixels are white. Let's open Pix. Launch the application. Let's do a GPU capture. Go to the pipeline. Select the box drawing event. Start the analysis tool. Select the texture 0. Everything looks fine. Select the texture 1. By selecting a few pixels, you can see that although the alpha channel is 0, the RGB values are 1. Open the texture in Visual Studio, display its background as black, and the RGB background values are 255. To fix this, use the Fill Transparent PNG pixels from online PNG tools. Load the PNG texture, define the replacement value as RGBA0000, download the texture, replace fragile PNG with this texture, open PowerShell, and use TextComp again to convert the texture to DTS. Go back to Visual Studio. If you select a pixel, you can see now that the RGB values from the texture's transparency are 0. Launch the application. Yes, the result is an oscillating box with two textures.